Hello, welcome to my Factorific channel. This is your Sir Mar, and at this point, I'm going to discuss with you the examples on how to make use or how to use the quadratic formula in finding the values of x, or how to use the quadratic formula in solving quadratic equations. By the way, there are three other methods that are used in solving quadratic equations, and these are extracting the square roots, factoring, and completing the square. The quadratic formula can be used when the three others are not applicable in solving quadratic equations. So our last resort would be the quadratic formula. Again, there are three examples I'm going to provide so you can master, okay, really the different processes on how to solve quadratic equations using quadratic formula. So we have here solving quadratic equations by using quadratic formula. The first example, or say, let us recall the quadratic formula first, and we express the standard form of quadratic equation. So our quadratic formula, as we have discussed in our previous video, we derive our quadratic formula by using completing the square, and we express also quadratic equations that are not transformed or expressed into quadratic or standard form of quadratic equation. So our quadratic formula is x is equal to, is equal to negative b plus minus the square root of b squared minus 4ac over 2a. And our standard form of quadratic equation is ax squared plus bx plus c equals 0, in which a, b, and c are elements of real numbers, and a must not be equal to 0. Okay, so there are going to be three examples to be given. First example is, so we have here, solve the following equations using quadratic formula. So solve the following equations. Okay, so if we say solve, we're going to find the values of x. We're going to find the values of x. So number one, we have 2x is equal to 3x squared minus 7. So notice that the given equation is not expressed in standard format. So we have to express first before we solve. Okay. So it is very important that we know how to express our equation into its standard form. So we have here 3x squared. So we move this one to the other side. So in moving this, we change the sign from positive to negative. So we have minus 2x here, minus 7. Or this can also be written as 3x squared. Okay. 3x squared minus 2x minus 7 equals 0. So here, since the needed data in our quadratic formula are the values of a, b, and c, so we need to identify the values of these variables or arbitrary variables. So we have a is equal to 3. So this is our a, this is our b, this is our c. So we have b is equal to negative 2 and c is negative 7. Okay, so using our quadratic formula, we have x is equal to negative b plus minus the square root of b squared minus 4ac over 2a. So by substitution, we have negative b, or our b here is negative 2, so we have negative 2 or negative of the negative 2 plus minus square root of b squared, which is negative 2 squared minus 4 times the value of a is 3 and times the value of c is negative 7 all over 2 times a is 3. Okay? So x is equal to negative times negative 2 is positive 2 plus minus the square root of the square of negative 2 is positive 4. Negative 4 times 3 is negative 12 times negative 7 is positive 84. And 2 times 3 is equal to 6. Okay? So we have 2 here plus minus square root of 88 over 6. Okay? And we have x is equal to 2 plus minus the square root of 88. So what are the factors of 88 in which one of the factors is a perfect square, since 88 is not a perfect square? Okay, so we have 4 and 22, correct. So we have 4 and 22. So if we're going to multiply these two factors, the product is 88 over 6. And we have here 2 plus minus the square root of 4 is 2 and the square root of 22 is a rational number all over 6. Okay? So we bring out the common factor of these two terms, which is 2. So we have 2 here. This must be our bar. So we have 2 here. We bring out our 2 here. And then what is left inside is 1 plus minus 1 times the square root of 22. But we don't need to write 1 here because it is understood that the coefficient of this or the integral value of this is 1 all over 6. Okay? So going further, we have x is equal to, okay, we cancel now our 2 and 6, and 2 over 6 becomes 1 over 3. So we have 1 plus minus the square root of 22 over 3. So that your x sub 1 here would be 1 plus the square root of 22 over 3, and your x sub 2 would be 1 minus the square root of 22 over 6. So these are the values or the roots of the given quadratic equations, and we find the values by using our quadratic formula. Okay? So that's how we make use of our quadratic formula. The second example, okay, number 2 example is 4x squared minus 12x plus 10 equals 0. Again, it's so easy to determine or identify the values of the values of a, b, and c here because the equations already transformed or expressed into standard format. Okay, so all we have to do is to identify the values of a, b, c. The value of a is 4 here. Our b is negative 12. And our c is 10. And, okay, the quadratic formula, don't forget, you must always remember this when you use quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. Okay? So we have x is equal to, so our b is negative 12, so negative of negative 12 plus minus the square root of negative 12 squared minus 4 times the value of a, which is 4, and times the value of c, which is 10, all over 2 times the value of a, which is 4. Okay? And we have here negative of the negative 12 is positive 12 plus minus the square root of negative 12 squared is 144 minus 4 times 4 is 16 times 10 is 160 over 8. And we have x is equal to, okay, 12 plus minus the square root of negative 16. So 144 minus 160 is negative 16 all over 8. And x is equal to 12 plus minus, okay, the square root of negative 16 is an imaginary or cannot be extracted because our radicand is negative. So we have to find ways so that we can extract the root, even if we result it to imaginary number. Okay, so negative 16 can be factored as 16, positive 16 times negative 1. Okay, just to simplify our radicand, so we can make use of our negative radicand, which is negative 1. So in that case, we have a specific value of this square root of negative 1 afterwards. Okay, so we have 8 here, and therefore we have 12. We have 12 plus minus square root of 16 is 4 times square root of negative 1 over 8. Okay, so we have x is equal to, now we can factor out the common factor here, which is 4. So 4, 12 divided by 4 is 3, plus minus 4 divided by 4 is 1, times the square root of negative 1 all over 8. And x is equal to, okay, our 4 and 8 can be divided by 4. So we have cancel 1 and 2 here. So we have 1 times 3 is 3 plus minus, okay, the square root of negative 1 is equal to an imaginary number. So we have I here all over 2. Okay, so that your x sub 1 would be 3 plus I over 2, and your x sub 2 would be 3 minus I over 2. So these are the values of x that we have obtained by solving quadratic equation using quadratic formula. Take note that the square root of negative 1 is I, or an imaginary number. Okay? And the last example, we have number 3, which is 5x equals 4x squared minus 6. So the format is similar to that in our number 1 example. So again, we have to express this into the standard form of quadratic equation, which is, okay, 0 is equal to 4x squared. And we move this one to the other side. And in doing so, we change the sign. That will become negative 5x minus 6. Or we have 4x squared minus 5x minus 6 equals 0. Okay? So in our quadratic formula, we have the negative b. What's our b here? It's negative 5. So negative of the negative of 5 plus minus the square root of b squared, which is negative 5. Okay? Minus 4 times a, which is 4, times negative 6, which is negative 6, all over 2 times 4. And x is equal to, okay, this is positive 5. Negative of negative 5 is positive 5, plus minus the square root of 25, plus, okay, 4 times 4 is 16, times 6 is 96. That is positive. So we have plus 6 here, or plus 96 all over 8. Okay, so we continue. X is equal to, we have 5 plus minus the square root of 25 plus 96 is 121 all over 8. Okay, and we have x is equal to 5 plus minus 121 is a perfect square, right? Okay, so if it's a perfect square, then we can extract its root. The square root of 121, therefore, is equal to 11 and over 8. So taking our first value, the plus and minus, we have x sub 1. Taking the positive value, we have 5 plus 11 over 8 is equal to 16 over 8 equals 2. And that is our x sub 1. And our x sub 2 is 5 minus 11, taking the minus sign or the minus operation over 8 is equal to negative 6 over 8 is equal to negative 3 over 4. Therefore, the values of our x in that given equation, okay, are 2 and negative 3 over 4. Okay, so 2 and negative 3 over 4. So again, we can make use of this quadratic formula when especially the 3 other methods fail to solve it. Okay, if the 3 other methods fail to solve it, but even if they are not, even if they can make use, they can use, even if they can solve quadratic equations, we can still make use of our quadratic formula. Okay. So again, I hope you have learned something this moment, and I hope that you have understood the use of our quadratic formula in solving quadratic equations. Thank you very much.